So grade 10, we are actually going to pick up from where we had left off from last time. We had actually started looking at a paper here, right? The grade 10 maths paper. This is the paper that we had started looking at. This is a March common test KZN paper, KwaZulu-Natal province. We started looking at this paper, guys, but we did not complete it, right? We actually literally ended here. Okay, we ended right there. We did, I think, this question, but then we were about to actually embark on this question. So we are going to pick up, all right, the session from here. All right, I do want to say that these questions that we did here, the video for the questions from question 1 up until question 1.5.3, you can find the live lesson for this video on my YouTube channel, guys. The link is in my bio for the YouTube channel, so if you want to check out my YouTube channel, you can actually check it out. All of these questions, we answered them, all right, already. The video is there. You can check it out in your own time, and you can spend some time looking at it. What grade? Grade 10, my guy, all right, or grade 10, my girl. We are busy preparing for the upcoming March common test. All right, we are looking at the March 2024 common test that was written in the province of the KZN in 2024. And you can see that the style of questioning is pretty much the style of questioning we can sort of expect in papers that we'll be writing in March. I'm not saying this is the paper, but I'm just saying the style of questioning is what we can anticipate. And obviously that does not mean we are limited to just these questions, but this will give us an idea. So we answered these, like I said, from 1.1.1 up until 1.5.3. That's what we answered from the previous live lesson up until this point. So if you want to check out what we did with these questions, you are more than welcome. Go to my YouTube channel, guys. I have no other thing to say. YouTube channel. All right, yeah. So this is basically the thumbnail of that YouTube video that I did on this paper. So if you go to my YouTube channel, you are going to find the thumbnail exhibiting this picture that you see on the screen. All right, yeah, the most recent video that I uploaded in my YouTube channel. The live lesson was a bit long. I think it was about above 2 hours, because I really did stick to these questions, but also I did add some more questions so that we could have at least, you know, a bit of flavor of questions. See if I can't get this up a little bit. Yeah, there we go. So if you see there, that is the thumbnail of the video, guys. The thumbnail of the video for the questions, like I said, 1.1.1 up until 1.5.3. Go find this YouTube video. It is a 2 hour and a bit YouTube video, and it covers the questions that I said are from 1.1.1 from 1.1.1 to 1.5.3. So today we are going to pick it up from 1.5.4, and we are going to continue further. Okay, so we are going to start right there. Okay, I hope you can see there, guys. 1.5.4, that's where we are going to start today. Okay, so let's start. Let's go. Okay, so the question says, what's happening there? My pen is not moving. Simplify. Okay, 3 over a minus 4 plus 2 over a plus 3 minus 21 over a squared minus a minus 12. So we are looking at this, and the question is saying simplify. So we are required to simplify this expression for how many marks, guys? A good 5 marks there. That's a good 5 marks. Okay, a good 5 marks. Sorry, guys, I just want to share this live. Please share the live to as many people as you possibly can. If you Okay, so I just had to share this live just to some more people. Okay, so we have 3 over a minus 4 plus 2 over a plus 3 minus 21 over a squared minus a minus 12. So guys, we've done simplification of algebraic fractions, I'm hoping, in our respective schools. Okay, there is multiplication, division, addition, subtraction, and all of that type of factorization, that type of simplification of algebraic fractions. So this one here, guys, is a question that says we need to simplify. This is not an equation, it is an expression. Guys, there's a difference between an equation and an expression. So this is an expression. Why? Because the terms 3 over a minus 4, that's one term, plus 2 over a plus 3, that's a second term, minus 21 over a squared minus a minus 12. These are 1, 2, 3 separate terms. There is no left hand side and right hand side. All right, because an equation, guys, if this was an equation, then this is what you would notice. If this was an equation, it would be like this. There would be a left hand side of terms and then an equal sign, and on the other side a right hand side of terms. Does that make sense? So that's an equation. But an equation, we are usually required to solve for an unknown. That's an equation. This is not an equation, it is an expression. So we are required to simplify it. So how do we go about simplifying a expression of this nature where we have addition and subtraction of fractions? Okay, the first step, guys, that we need to take in solving or simplifying an expression of this nature is we need to first look at the denominator. Look at it, guys. Okay, before even looking at it, look at the expression and ask yourself, how many terms do you have in the expression? So of course the fraction is one term, plus sign separates this fraction, second term, minus sign separates this. Here is a third term. So you have 3 terms in your expression and the relationship is one of plus and minus. You then thereafter look at the denominator and factorize if possible. Factorize if possible. So let's look there. 3 over a minus 4. You see me put this in brackets, guys. That's an indication that I see that in this expression in the denominator, there's a common factor, which is 1. So I take that out, all right? An invisible one, by the way. And then a minus 4 I put in brackets to indicate factorization, plus 2 over, same thing with a plus 3. There's a common factor of 1, brackets there, minus 21 over, now what do you see here, guys, in the denominator? Okay, what type of expression is this in the denominator? Okay, for those who have just joined in, guys, I am busy answering a March 2024 common test paper written in KZN. Okay, these questions have already been answered from 1.1 to 1.5.3. I answered these in my previous live that I did for grade 10s. I have then saved that live lesson on the YouTube channel. So if you want to check out on me answering these questions in detail and also answering other related questions, just to make sure that you guys have a deeper understanding of this, you can go watch my 2-hour live lesson, guys. It's there uploaded on the YouTube channel. The link to my YouTube channel is in my bio. You can go and spend some time and watch that YouTube video. It really will be worth your time. That's from 1.1.1 up until 1.5.3. Today I'm picking it up at 1.5.4 with the anticipation that I'm coming this side to answer these questions. Okay, all right, back to the simplification. What do we see here with this denominator? A squared minus a minus 12. Okay, yes, thank you. A quadratic what trinomial. So therefore that means we can factorize this, because we said the first step is to look at the denominator and factorize if possible. So we've done that there, we've put those in brackets. Now we can do that there. So when we factorize a quadratic expression, we open two brackets, of course. The minus sign, the constant, when it is minus the last term, it means we are going to have different signs. The signs are not going to be the same. So we are going to put a minus sign and a plus sign to show that the signs are not the same. But we know, because of this minus sign, that the highest factor out of the factors of 12 is going to have a negative sign. I repeat, the highest factor out of the factors of 12 is going to have a minus sign. So now I'm going to think about factors of 12. I have 12 and 1, 6 and 2, 4 and 3. And we are saying that the highest factor is going to have a sign of the middle term, a negative sign. So which two factors here, when we add them together, will give us a negative 1? Is it negative 12 and 1? Is that what is going to work here? Is it negative 6 and 2? Is that what's going to work here? Or is it negative 4 and 3? Which one works, guys? For the factors of 12, which when I multiply give me negative 12, but then when I add them give me the coefficient of the middle term, which is negative 1. Okay, thank you so much. I see this active participant in the comment section who's basically, let me see, who are you? Pilantuli. Alright, Pilantuli is intuiling here. Oh my soul. What a battle between the profile picture and the bio. My goodness. Like, those are what you might call juxtaposed, and they are opposites, polar opposites. Okay, minus 4 plus 3. Minus 4 plus 3. Very good, guys. Very good. Then, since it's a that we are dealing with, obviously a times a will give you a squared. So that is the factorization of a squared minus a minus 12. This is 100% correct. My factorization is on point. So I'm happy with the simplification, the factorization of the denominator. Step number 1 has been done. Step number 2, LCD. We need to write down the LCD. So guys, what is the LCD of a minus 4, between a minus 4, a plus 3, a minus 4, and a plus 3? Remember that when we write down the LCD, we're writing down the product of the number, the coefficient number, times the lowest common multiple letter times the lowest common multiple bracket. Lowest common multiple number. So when we're looking at the lowest common multiple number, we are looking at, if we have brackets, we are looking at the number before the bracket. So here we have 1 that we don't see, we have 1 that we don't see, and then we have 1 that we don't see. So our lowest common denominator number is 1. We multiply that with what? The letter. Now, letter wise, the variable needs to be a variable before the bracket. Do we have a variable here before the bracket? No. Do we have a variable here before the bracket? No. Do we have a variable here before the bracket? No. So that means we do not have a lowest common multiple letter. Then we go to bracket. The lowest common multiple bracket. That is the common bracket that has the highest exponent. Okay, so we look at a minus 4 when we ask ourselves, is a minus 4 common? All right, a minus 4 exists for this denominator. A minus 4 also exists for this denominator. So what do we notice about this a minus 4? It is not common for all 3 fractions, but it is common for 2. And I suppose that is enough. If it is common, or even if it exists as a unique bracket, we would definitely include that as part of our LCD. So what we do is we look at this a minus 4, a minus 4, a minus 4. We can then take a minus 4, the bracket which has the highest exponent for a minus 4. both of these a minus 4 brackets have the exponent 1, so does this one as well. So we can then say a minus 4 is part of our LCD. It is a leftover bracket, not common for all three of the fractions, but the common bracket with the highest exponent for these two is the one that has the exponent 1. So we take that once as part of our LCD. Then we look at another bracket that is there. We have a plus 3. A plus 3 is different from a minus 4. It is common for two fractions. So as a leftover common bracket, we take the common bracket with the highest exponent. So we can see a plus 3 exists with the same exponent both for this denominator and that denominator. So that means the product of a minus 4 together with a plus 3 is what our LCD will be composed of. So our LCD, guys, is a minus 4 times a plus 3. That is the LCD. Okay. Step number 3, equivalent fractions. What are we talking about? We use the LCD to form equivalent fractions. What do we mean by equivalent fractions? The LCD that we have, which is correct, a minus 4 into a plus 3, we are going to use that to form fractions that have the same denominator like the LCD. So all you do, guys, to simply do this is you are going to look at this LCD and ask yourself, in this fraction, who is missing in the denominator? I say again, in this fraction, who is missing in this denominator so that we are like the LCD? Who is missing here? A minus 4 is there, all right, but who is missing? It's a plus 3. So what we do, guys, is we simply put a plus 3. I'm just going to use a different pen so that you guys can see who is missing. A plus 3. But remember, what you do at the bottom, you must do where? At the top. Okay. Now what we see in this denominator, it is no longer just a minus 4, but it is a minus 4 into a plus 3, just like the LCD. Right? We just needed to multiply this a minus 4 with a plus 3. But what we do in the denominator, we must do in the numerator. This is an equivalent fraction of 3 over a minus 4 with the LCD in it. Done. Let's move on to the second fraction. Who is missing in the denominator so that we are like the LCD? A plus 3 is there. Who do we need now? A minus 4. So what we do is we multiply by a minus 4 at the denominator. But what we do at the denominator, we do in the numerator. Okay. Then last but not least, we go to the last fraction. Who is missing in the denominator? No one is missing in the denominator. Okay. So that means this fraction already has the LCD and therefore it is safe. Okay. We could say we could multiply by 1 and 1 at the top and the bottom, because we know that multiplication by 1 basically still gives us the same identity of the denominator and the numerator that was there. Okay, now fractions. In fractions, there's this thing that says when we are adding and subtracting fractions, if denominators are the same for your fractions, all of them, if denominators are same, you can then add and subtract what? Add and subtract the numerators. Numerators. When the denominators are the same, you can then add and subtract the numerator. So what we are going to do now is that we have established that all of these fractions have the same what? Denominator. So I'm just going to write a minus 4 into a plus 3. That is the lowest common denominator for all three of these fractions. The equivalent fractions have led me to that conclusion. Now all I do is I focus on the numerator. So what do I do now? 3 multiplied by a, 3 multiplied by 3. 3 times a, that's 3a. 3 times 3, that's plus 9. Then we move on to the next term. Positive 2 times a, positive 2 times negative 4. What's 2 times a? Positive 2a. What's 2 times negative 4? Negative 8. And last but not least, we have negative 21. So we just simply put negative 21 next to those terms. Then we finish off, guys. We add and subtract like terms, because we said if denominators are the same for your fractions, you can then add and subtract the numerators. So now we're going to look at like terms, add and subtract them, and then simplify. So we have 3a plus 2a. Those are like terms. We know 3a plus 2a is 5a. 9 minus 8, that's 1. 1 minus 21, that's basically negative 20. That's all over a minus 4 into a plus 3. Guys, the denominator, do not multiply the denominator out. Leave it with those open brackets still there. Why? I'm going to say this. Leave your denominator with open brackets even until the end. Don't try and multiply out the denominator. Leave the denominator with open brackets. Just sort out the numerator. Now that we are here at this stage of 5a minus 20, the last thing we are going to check is, can we factorize the numerator in such a way that it will lead to further simplification? Can we factorize the numerator so that it leads to further simplification? That is something that you have to ask yourself after having added and subtracted the like terms in your numerator. You ask yourself, can you factorize the numerator in such a way that it leads to further simplification? So if you look at the top there, I can see that there's a common factor of 5. I take it out. What's left inside? Okay, a minus what? 5 times what gives you 20? It's 4. That's all over a minus 4 into a plus 3. Now, of course, those two brackets, can we cancel a minus 4 and a minus 4? Yes. Why? Because they are common brackets, and the relationship of 5 with a minus 4 is one of multiplication. The relationship of a minus 4 and a plus 3 is also multiplication. So then cancellation happens very nicely, and we are left with a sweet answer of 5 over a plus 3. And guys, we cannot simplify any further. Even if, let's say, in this denominator there was an a plus, let's say, a 5 here, we would not be able to cancel the 5 and the 5. Why? Because we do not cancel across an addition or a subtraction sign. We do not cancel across an addition or subtraction sign. So our final answer would be right there. We'll be left at that stage. So guys, this is how we simplify a fraction expression. This is not an equation, but it is a fraction expression. What is an expression? An expression is not an equation, because an expression is a list of terms separated by a plus or a minus sign if it is multiple terms or something like that. Question, am I allowed to rationalize it? Remember, rationalizing, okay, is applicable to when you are dealing with the presence of a third in the denominator. Here we have a plus 3. This is not a third, so rationalizing the denominator here is not applicable. Okay, so very important, guys. that when we do these types of questions, we first look at the denominator. That's the first thing we do. We then factorize it if possible, which is why a minus 4, we put it in brackets initially, a plus 3 we put in brackets, and then a squared minus a minus 12 we factorized using our understanding of trinomial expressions to get a minus 4 into a plus 3. That's how we got the factorization of a squared minus a minus 12. Then 2, we write down the LCD. We wrote down the LCD and we identified that the LCD is a minus 4 times a plus 3, because a minus 4 is common and a plus 3 is common, and they are the common brackets that possess the highest exponent. So we write a minus 4 and a plus 3 as products of each other, and we record those as LCDs. Then we form what we call equivalent fractions of these fractions using the LCD, which is correct. So that's how we got 3 over not just a minus 4 anymore, but we asked who is missing from a minus 4 in order for us to have the LCD, and we found that a plus 3 was missing. So we multiplied by a plus 3 in the denominator, but what we do in the denominator, we do in the numerator. We did the same thing with this fraction. We asked who's missing in the denominator in order for us to have the LCD. We saw that a minus 4 was missing, so we multiplied by a minus 4 in the denominator. We repeated that multiplication in the numerator. Then we asked who's missing here, and we saw no one was missing. So we simply multiplied by 1 so that we retain that fraction. After doing so, we wrote our LCD because it's common for all 3 fractions. A minus 4 into a plus 3 is common for all 3 fractions. The rule in fractions says if the denominators are the same, you can keep that denominator as it is. You then add and subtract the numerators. That's why I could now apply my understanding of BODMAS. Take 3, distribute it into the 2 terms, get 3a plus 9. Take 2, distribute it into the 2 terms, get 2a minus 8. Then minus 21 is there safely put. I add and subtract the like terms in my numerator. I get 5a minus 20. After getting 5a minus 20, remember guys, you don't touch the denominator. The denominator, if it has open brackets, you leave it like that. Then at the end, if you can, you factorize the denominator so that you can see if further simplification is possible, and then you get your nice simplified answer, and you are happy, and it's great, and you're amazing. Guys, how sweet is this? The maths, it's so nice, step by step, just a flow, seamlessly, a flow of seamless mathematics that basically yields beautiful marks. Okay, guys, continue to share the live. Continue to share your live, share the live with all your rich aunties and uncles. Let them come down here. Let them come and support me here in the live. Let them come and gift me, guys. I love gifts. I'm not going to pretend as if I don't like gifts, guys. Like on my my live goal there, I've got 1,000 roses that I would love to actually have met before the end of the night if possible. So any of my potential gifters in the house, holler at your maths is a game, guys. Please do support the live creator. It would be great. I love gifts. I am not going to even hide it. I love gifts. So if you can send a rose or send roses, that would be great, as many as you possibly can. If you can't, send the live to your rich aunties and uncles, your sugar mummies and your sugar daddies and everyone that's sugary, and let them come here and just share the goodness. Okay, let's move on, guys. We are going to now enter into question 2. Solve for x. All right, now we are entering into the equation stage. We've done expressions, algebraic expressions, factorization, simplification, and then also we had dealt with number systems. Like I said, those who missed this segment of the problems that I did, you are more than welcome to go to my YouTube channel. I did a live lesson on this. It's like 2 hours and a bit, because it was a full jam-packed explanation kind of live where I did above and beyond these questions so that as to cover the scope of the types of questions that can possibly come up. So please do check it out. It will be worth your time. 2 hours and a bit, definitely worth your time. You could even watch it in segments and not all at once. Then let's get into equations. solve for x. You can see there we have the x plus 3 into x minus 1 is equal to 0. 2.1.1, guys. Ngosingipile, it is Maths is a Game. It's also still Maths is a Game on YouTube, but the link is in my bio if you want to get access to the YouTube channel. The link to my YouTube channel is on the bio. In my bio, the homepage of this TikTok page, the link is in my bio. It's Maths is a Game 5 to 7. All right. Profile picture is white. I have roughly 2.6 and a bit followers now. Yeah, thanks to your guys' generous following and subscribing. So thank you so much. I'd really appreciate your follow as well there, and liking, commenting, and doing all sorts onto the videos. The quality is not the best, guys, because I'm literally just uploading live lessons that I've done here onto that channel. But hopefully people who know my style of actually doing these live lessons can just sort of like enjoy what is there. Okay, so let's look at this one. 2.1.1, x plus 3 into x minus 1. I'm hoping you guys are also writing with me and you're answering the questions I had. It would be great. There, this one for 2 marks. Surely it's 2 marks because it just is straightforward. X plus 3 into x minus 1. Maths is a Game is the name of the YouTube channel, guys. Maths is a Game. It's got a 5, and then it's like capital letters. Maths is a Game 5 to 7. Okay, so that's like the Maths is a Game 5 to 7, which is pretty much the handle I'm using here as well. But the link to the YouTube channel is in my bio. So if you go to my bio in the homepage, the link that is there is the YouTube channel link. You can click on that and you can move from there here. The profile picture is white with the emblem of Maths is a Game, which is white, having a white background. So it's different from this green background that we have here, but it's got a white background. It kind of resembles the TikTok page that I have for grade 11s to 12s, because this one I use for grade 8s and 9s and 10s, this page. Okay, all right, x plus 3 into x minus 1 is equal to 0. How do we move here, guys? What come on, comment section, let's go wild. Right, we are currently here. We are in a step where we have just completed what? Factorization. Factorization has happened and it has led us here. That's where we are now. We are x plus 3 into x minus 1 is equal to 0. We are coming from standard form. We are at the factorized stage where we've opened 2 brackets, all right, equal to 0. Now, what do we do as we proceed further? We apply what we call the zero factor law, and it's called the zero factor law, guys, simply because there must be a 0 on the other side in order for this law to be in effect. Factorization, factored, a product of factors, multiplication of factors, together with zero factor law. So we apply the zero factor law, and that is, we do this. We just say x plus 3 is equal to 0 or x minus 1 is equal to 0. Then we write down our solutions. We are going forward, guys, not backwards. Okay, we are going forward here, not backwards. All right, take note of the way that we are moving here. Okay, x plus 3 into x minus 1 is equal to 0. We are given the question, it is at this stage already. So if you decide to FOIL, all right, you say x times x, x squared, x times negative 1, negative x, 3 times x, 3x, 3 times negative 1, negative 3. You add the like terms. It's like you are going backward a step. What you need to do is you need to move forward a step, because you are already at the stage, all right, where you have 2 brackets which are a product of each other. These are factors of a quadratic trinomial that you had previously. This is at the factor stage. So from the factor stage, you must move forward and apply what we call the zero factor law. Okay, we are solving for x here, guys. We are solving for x. We've left simplify. Now we are deadbeat at solve for x. The reason you can be confident that we are at solve for x is because you can see here we have a product of factors, but on the other side there's an equal to 0. So this is an equation. It's an equation, not an expression. It's an equation. So we move forward. You take x plus 3, make it equal to 0, or x minus 1. You say it's equal to 0. This is what we call the zero factor law. The zero factor law, guys, says if a times b is equal to 0, then because a and b are products, multiplication, we say a is equal to 0 or b is equal to 0. So this a is just like this first bracket, x plus 3, multiplied this b is just like this x minus 1, the second bracket, and they are both equal to what? 0. What does the zero factor law says? It says the product of factors equated to 0, because this is called the zero factor law. So it only applies this law when we have a 0. Then what do we say? We say a, the first factor, is equal to 0, or b, the second factor, is equal to 0. So that's why we say here x plus 3 into x minus 1 is equal to 0. We take the first bracket, we equate it to 0, or we take the second bracket, we equate it to 0. Why are we doing this? Because the zero factor law says so. And then we can write our solutions. We take the positive 3, we transpose it over to the other side. When positive 3 gets transposed to the other side or moves to the other side as a term that is added to x, it becomes negative 3. Same thing with negative 1. When negative 1 gets transposed to the other side, it changes from negative to positive 1. So that is why we say x is equal to 1 or x is equal to negative 3. All right. Thank you so much, Raising Queens. Karab, I really appreciate the gifts there. Very generous with the gifts. I really appreciate it. The roses, the works, getting that rose gold there, up there. We've got 12 roses now, out of 1,000. Thank you so much. Really appreciate it. Means the world. Okay, means the world. Okay, you see, so x is equal to negative 3 or x is equal to 1, right? That is the solution. 2 marks in the bag. That answers that question. Okay, 2 marks. That answers that question. Let's look at the next question. Okay, yeah, in this question paper, I can see the KZN setters, they set the paper. Look at this one. Solve for x. 2x squared minus 5x plus 2 is equal to 0 for how many marks? For 3. 2x squared minus 5x plus 2 is equal to 0. Grade 10. Karab, we are busy with grade 10 here. Right? What, did you have a request? Is that why you're sending me gifts? Because you have a request. 2x squared minus 5x plus 2 is equal to 0. Guys, this here is a trinomial, right? But as you can see, this trinomial has a coefficient of x squared which is not 1, but it is greater than 1. Secondly, this coefficient is not a highest common factor because it's not a factor that's common to the term here. So therefore, we need to then look at this trinomial and ask ourselves, what type and method of factorization can we apply for this trinomial, right? Yes, it's an equation, but we want to apply an appropriate method of factorization for the trinomial. So if you remember, when you did your factorization, you guys looked at a method of factorizing when x squared has a coefficient that is not 1. Okay, so here we can apply that AC method. Okay, remember the AC method, where you take the coefficient of x squared, which is basically a here, which is 2, and then you multiply it with the constant term, which is c, which is also positive 2. So you take this positive 2 and that 2 and you multiply them together. So a times c, which is 2 times 2, that gives you 4. Okay, that gives you 4. So this 2 times this 2 gives you 4. Then you try and find what? The factors of what? Of 4. All right. Okay. These factors of 4, when you add them together, they must give you -5. I repeat, you want the factors of 4. Factors of 4. And because this is a positive, it means that these factors must possess the same sign. Because this 4 is positive, positive means these factors need to possess the same sign according to the sign of this middle number. What is the sign that we have here? Negative. So the same signs of these factors need to both be negative. Now you're thinking of the factors of 4. And when you think of factors of 4, you're thinking of 4 and 1. 4 and 1. Yes, there's 2 and 2, but you know 2 and 2, when you put them together and they're both negative, you are never going to get -5. So we're not going to waste our time think of 2 and 2. We are thinking of 4 and 1 because -4 minus 1, that gives us a -5. Let me repeat this again. What did we just do? We said, take the coefficient of x squared, which is 2, multiply it with the constant last term. What is that? 2 times 2, which gives you what? A positive 4. The 2 here is positive. The 2 there is positive. Let me repeat. The 2 here is positive 2, which is A. The 2 here is positive, which is C. You multiply A and C. Like, you know, most A and C is the political power that is in power. You take A and C, you multiply them together, you get 4. This 4 is positive. What does 4 that is positive imply? It implies you are going to have the same signs. Guys, if I had gotten a negative, that would mean it would imply we'll have different signs. But when you ever have a positive, it means same signs. Negative means you have different signs. Positive means same signs. Negative means 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 different signs. But since this is a positive 4 and it means same signs. Same signs according to who? According to B. Who is B? According to the sign of the middle term. So I'm thinking of the same signs that I need to get for the factors of 4. All right, they need to be same according to this sign. So they need to be both negative. That's what I said to you. Which are the factors of 4, which when I add together, whilst they are both negative, will give me a -5. All right, guys, it's 4 and 1. 2 and 2 won't work because -2 will give me -4. This is not -4. So 4 and 1, which are both negative, they work. Do you know what I do then? I just put an x and an x, and then I take these guys, they come and replace my -5 here. -5x. Check this out. So let's rewrite this expression. -4x minus x minus x. This here has just replaced -5x. Then we write the +2 there at the end. Now, when we have this, paradise has come. I can now confirm what is there. 2x squared, 2x squared. What did I do to -5x? Remember, I had taken the 2, multiplied it by 2, gotten a 4. Taken the 4, found out what sign it is. It is positive. That means same signs. Same signs according to who? According to the sign of the middle term. That means factors of 4 need to have the same signs according to who? According to this guy. All right, so that's why the factors of 4 and 1 works properly. 2 and 2, 2 and 2 won't give me -5. 2 and 2 will give me -4. I need 4 and 1 when they both have a negative sign. I just plug in the x next door to them, and then I replace -5x with these two terms, -4x and -x. Now I'm going to apply grouping factorization. You know grouping, guys? Grouping factorization, because grouping factorization was done in grade 9. Now you're doing it in grade 10 as well, and you are using it to basically solve a advanced trinomial. So let's group a pair of terms. We are going to group these pair of terms in a ratio of 2:2. In other words, a pair of terms with another pair, we are going to group and factorize. So I'm going to mentally group these two terms and ask what is the highest common factor between 2x squared and -4x. Remember, when you take out the highest common factor, guys, the movies that we don't watch, we take out the highest common factor according to what? The movie. S means sign, N means number, L means letter. We take out the sign, number, letter. So between 2x squared and -4x, which is the highest common factor sign? Highest common factor sign is the sign of the first term, so it's a positive. Between 2 and 4, we moved on from sign, we move on to the number. 2 and 4, what is the highest common factor between 2 and 4? Highest common factor between 2 and 4. Highest common factor between 2 and 4 is 4. Guys, you see, now those are people I need to give a hiding, serious hiding. Highest common factor, guys, is the common base. Okay, we would say common base with the lowest exponent. All right, so between 2 and 4, you are thinking of the factors of 2 and the factors of 4. Factors of 2 are 1 and 2. Factors of 4, 1, 4, 2. So which one is the highest number, which is common for both? It's 2, guys. Please don't ever say 4, man. Guys, highest common factor between 2 and 4, get 2. Right? Then between x squared and x, what's the highest common factor letter between x squared and x? Remember, highest common factor letter is the common base with the lowest exponent. So it is x. It can't be x squared. Okay, please, guys. Okay, between 2 and 4, the highest common factor number is 2. Okay, the number that goes into 2 and 4, the highest number that goes into 2 and goes into 4 without leaving a remainder is 2. It's not 4. Okay, then the highest common factor letter, when we talk about highest common factor letter or variable, we say it's the common base with the lowest exponent, not the one with the highest exponent, the common letter with the lowest exponent. So x squared and x is common, but which one has the lowest exponent? It is x. So we take out that 2x, what's left over inside the bracket? 2 times what is 2, x times what is x squared. We know there's an x that's left over there for the first term. Then 2x times what is -4. We know the sign is still negative, but then it's -2. We close the brackets there. That is the highest common factor with what is left inside for these first two terms. Then we look at the last two terms. We do the same thing. Remember, I said highest common factor what? Sign, number, letter. So if you look at these two terms, the first term of these two is a negative. So you always take out the sign of the first term in the terms that you are looking at as your highest common factor sign. Highest common factor sign is minus between negative and positive, because this negative is your first term. So like I said, the sign that comes first is always the highest common factor sign that you take out. Number, there's a 1 here that you don't see, and 2, it's 1. The highest common factor is 1. Then letter, x is not common. There's no letter that is common, so we don't have a highest common factor letter. So we take out -1. And guys, the minute you take out a negative sign, it means that the signs inside your bracket are all going to change. This term was initially negative, but inside now it is positive. This term was positive, but now all of a sudden it is negative, and it's negative 2, because negative 1 times negative 2 gives us positive 2. Okay, now what do you see? Key common bracket into it. So we take out Mr. Common Bracket. When you take out the common bracket, what gets left over on the left? See, when I take out this common bracket, who gets left over on the left? Kimang, ka left over, ka left. 2x. If you hide this side, Kimang are left over, ka other side, Kimang or left over, ka murao, -1. Okay, now inside this bracket, can you simplify any further? Is there any addition or subtraction you can do? No. Inside this bracket, any addition or subtraction you can do? No. Any further factorization that can be done? No. So this is the answer. All right. No, I'm kidding. That is not the answer. That is the way to the answer. Remember, we were not factorizing alone. We were solving an equation. So now that we are here, we are at that factorized stage. We have eventually factorized these two brackets. Okay, now we can proceed. Okay, now we can proceed and we can apply, after factorizing, we can apply the ZFL, the zero factor law. So this bracket, sorry guys, I didn't need to put this equal sign because this was not an expression, it's an equation. There's already an equal sign in between. Okay, so now we can go ahead and apply the zero factor law. So we say x minus 2 is equal to 0, or 2x minus 1 is equal to 0. Remember, what did we say the zero factor law means? The zero factor law says if there's a product of factors equated to 0, all you do is you take this first factor, make it equal to 0, and you put the word or. You take the second factor, you make it equal to 0. So in the same way, these are the product of two factors equated to 0. So now all you do is you take this first bracket, make it equal to 0. Take this second bracket, make it equal to 0. Then you can solve the linear equations. Take the -2 over for this first equation, you get x is equal to 2. Heartbroken, if you're in grade 11 and 12, you can. But for grade 10s, okay, which is basically the grade I'm actually focusing on at the moment, because this is for a grade 10 Mathematics March 2024 common test. So for the grade 10s, no, they do not, as of yet, have the workings of the quadratic formula, because it's not taught at their level. So they have to apply factorization that's appropriate for the situation. Okay, then here this side, 2x minus 1, we say 2x, we take the -1 over, and of course what do we do now? We divide both sides by 2, we get x is equal to half. So those are our two answers, x is equal to 2 or x is equal to half. We are safe and we are happy and it's great. Okay, so those are your two solutions, guys. Okay, after applying the zero factor law, you then get your roots. Okay, we call these answers x is equal to and x is equal to half roots of the equation. The solutions are referred to as the roots of the equation. The roots. All right. Okay, that was not too shabby, was it? Okay, guys, let's move on. Okay, so this is part, like I said, this was from that exam paper. We had this first solve for x question, really quite straightforward. This one, okay, maybe just a tad bit requiring that advanced trinomial factorization that we all love and know, where we have to actually first factorize utilizing our either you can use your advanced AC method, where you have to, as I said, multiply the a and the c together first, you get 4, then find the factors of 4, which when you add together give you -5. You get that -4x and that -1x, which are the appropriate factors. You then apply grouping for these even number of terms, these 4 terms. You group in the ratio of 2:2. In other words, you group a pair, all right, a pair of two, a pair of terms. So then you take out the highest common factor for these two, which is 2x. It leaves you with x minus 2. You do the same thing with these last two. You take out your highest common factor, which is -1 in this situation. You write x minus 2. Then you take out your common bracket. You write what's left over. You make that equal to 0. Then at this stage, you can really then, because you have factorized, can now apply the zero factor law, because there is a 0. There's a product of factors. You equate each bracket equal to 0, and then you solve each linear equation by isolating x on its own, applying the additive inverse and the multiplicative inverse for this particular situation, and you get the two roots that at most you should always get when solving for an equation. At most, guys, at most, right? Guys, if you're liking the live and you really are loving it, do share the live with your rich uncles and aunts. You know, I'd love them to come here and support the live stream. I have a live goal here, guys. Genuinely, I love gifts, and I really do. Like, they make my blood boil and my heart be happy like you have no idea. So if you guys can actually support my live goal, it really means a lot, as I do this nice work that you guys are probably either enjoying, or you are hating, or you are silently just hating everything that I'm doing. Okay, so anyways, 2. This is another one. Solve for x, guys. As you can see, this is an equation which is exponential in nature. What we can see is we have a 2 in brackets, which is a prime base. We have an exponent, 3x minus 1, which is an exponential expression there, equal to 64, which we have on this side. So when you look at this question, guys, you have a base, prime base 2. And I think what you want to achieve is to have the same base as well on the other side, so that you can then apply a important property, because in exponential equations, there is a property that says, simply put, if a to the power x is equal to a to the power y. So in other words, if you have isolated on either side of the equal sign the same bases, a ki base efanana le, same as this one. So if the bases are the same, then you can simply say x, which is an exponent, you drop it down, is equal to y. You also drop down the y. So it's almost as if you drop the base, you can equate the exponents. But the condition is that the bases must be the same in order for you to drop and equate the exponents. Does that make sense? So here we have 2 to the power 3x minus 1. 2 is in brackets already. It's raised to the power 3x minus 1. So we have 64 here. So if we look at 64, can we change 64 so that it has the base 2? How do we go about that? What is basically 64 as a prime base 2? Habiba is like Justin Bieber. Okay, Habiba is saying 2 to the power 6. Is Habiba 100% correct? Could we change 64 to 2 to the power 6? Is that the accurate representation of 64 as a prime base factorized exponent? Is that how we express 64? Guys, if you don't know and really you are lost, then your scientific calculator can also help you. You simply type in 64. You press 64, you press equal, you press shift in your calculator, and then you press fact. 64 is equal to shift fact. It will give you 2 to the power 6. Okay, so you can rewrite this as 2 to the power 3x minus 1 on the left. Then here we write 2 to the power 6. So now what do you see? As per the property of exponential equations, the bases are now successfully the same. So what do we do when the bases are the same? you can go ahead and you can drop the base. Drop the base, equate the exponents, or make equal the exponents. So base 2 is the same now. We can just say 3x minus 1 is equal to 6. Then what do we have here? A linear equation. We have a linear equation because the variable has the exponent 1. That's the highest exponent of the variable x. So it's a linear equation. The whole point of a linear equation is to isolate, leave x alone on the left. So negative 1 crosses over. What happens when negative 1 crosses over? We add 1. Basically, guys, what I need you to understand is that we are applying something that we call the additive inverse. You add 1 to get rid of negative 1 on the left. But what you do on the left, you do on the right. So if you add 1 here, which is the additive inverse of negative 1, it's the addition of 1 that leads to the negative 1 disappearing. But what you do on the left, you do on the right. So the addition of 1 is because of that. Okay. Now that we've isolated, we then have 6 plus 1, which is 7. Okay. 3 needs to go. What is the relation of 3 with x? It's multiplication. So you apply the inverse of multiplication. So the multiplicative inverse is what we apply here. But what we do on the left, we must do on the right. So then our final answer is x is equal to 7 over 3. We are done. That is basically how we solve this exponential equation, and it really wasn't that shabby. Okay, really wasn't that shabby. Okay, nice question, right? Very nice question. Let's move on to the next one. 27 to the power x, that's a minus 2, is equal to 81 to the power 2x plus 1. So once again, a base isolated there, another base on the other side isolated, it's raised to the power 2x plus 1. So what do we do here? 27 and 81, they need to be changed so that we can see them having the same base. But what do we change them to? 27, guys, how can we express 27 so that it has a base that is a little less than 27, but obviously is a prime number? We say these numbers are composite numbers. Numbers that have more than 2 factors, we call them composite numbers. So 27 and 81 are what we call composite numbers. But we want to change those to become prime numbers or prime bases. So how do we convert composite bases or composite numbers to prime bases? You remember, guys, I did say to you, using your calculator, you can convert 27. Okay. If you don't know, you simply press 27 in your calculator, your scientific one, the Casio calculator. You say 27 is equal to shift, you press shift and then you press fact. You press in 27, you type it in, you press equal, you press shift, then you press fact. And what you'll see is you'll get 3 to the power 3, like CI Express said. So we're going to write 3 to the power 3. When we write it down, you put it in brackets. And then because there's an expression x minus 2, you put that right up there in your exponent. Write this 27 as 3 to the power 3 in the brackets. Raise it to the power x minus 2. Does that make sense? Then you do the same thing with 81. You take your calculator. 81 is equal to shift, then fact. You get 3 to the power 4. Okay, so once again, 3 to the power 4, 2x plus 1. Okay, now we're getting close. The next thing you do, once you have this 3 needs to be distributed to x. The same 3 needs to be distributed to -2. Some people prefer to put brackets like this, all right? Because remember, this is an exponential expression that possesses 2 terms, x minus 2. So this 3 must be distributed because this is like a monomial, 1 term of 3 multiplied by a bracket of 2 terms. Okay, so therefore that's why we distribute. Then we get 3 to the power 3x minus 6. Okay, because of the distribution. The other side we do the same. 4 times 2x, 4 times 1. So we get 3 to the power 8x plus 4. Safe, sweet. Now the bases are the same. Okay, so when the bases are the same, what do we do, guys? We drop the base. We take 3x minus 6. We make it equal to 8x plus 4. So 3x minus 6 is equal to 8x plus 4. This is a linear equation because look at the exponent of x. It's positive 1 that you can't see. This exponent of x is positive 1. This is a linear equation because the highest exponent we have for the variable is 1. So then we just isolate x on one side. Remember the 8x is transposed, so it was positive. On the other side it becomes, the -6 is negative this side, so when you transpose it becomes, and then 3x minus 8x. Whenever you are adding like terms, you keep the variable, you add and subtract the coefficients. What's 3 minus 8? Let's see in the comment section if you guys can give me what 3 minus 8 is. 3 minus 8. 3 minus 8. Ebana. Thank you, Sia Express. Mohoshadi, Homoto, and Atubi. Atubi, why did you? Atubi was if you don't mind, if you don't mind. What was that? If you don't mind, what were you saying? Don't mind. If you don't mind, what for? What? Okay. Is that Atubi? I saw it. If you don't mind, it just didn't make sense. What were you talking about? -5x is equal to 4 plus 6 is 10. Okay, 4 plus 6 on the other side is 10. Then what do we do now? We let it go now. We divide the -5x by coefficient -5, but what we do on the left, we do where? On the right. Yes, yeah, Express. We do the same on the left and the right. The final answer is x is equal to positive divided by negative is negative, and then 10 divided by 5. That gives us a -2. Let's be careful, Mohoshadi, it's not -half. Remember, you are dividing the left by -5. That's what you are doing. Why are we dividing by -5? Because the current coefficient of x is -5. So you divide by the exact same numerical coefficient. But what you do on the left, you must do where? On the right. So you divide by -5. 2 positive divided by negative is negative, and then 10 divided by 5. I say it is 2 because 5 goes into 10 2 times. Okay. Yeah. Okay. Exponential equations seem to be done. Now, 2.2. Solve the inequality. -2 less than 4 plus 2x less than equal to 6, and represent the solution in the interval notation for 4 marks. Okay, so let's look at this. Solve the following inequality and represent the solution in interval notation. Okay, so we have -2 less than 4 plus 2x less than equal to 6. What is the goal and the objective? What is this, by the way? It's an inequality because an inequality will have your less than or equal sign, your greater than sign, or your greater than or equal sign. So what you have here is what I call a compound inequality because it has 3 regions: the area of smallest number, the expression with x that is in the middle, and then the highest number that is in existence for this particular inequality. Small, big, then the expression here. Okay, so the objective here is to isolate x in the middle, right? And you can do that successfully by doing the same thing starting from the middle. So currently what you have is 4 plus 2x. Okay, 4 plus 2x. This expression here, 4 plus 2x, we need to find the value of x, okay, that lies between -2 and 6, where -2 is not included, but 6 is included. Okay, so I repeat again, this is a compound inequality. We call this a compound inequality. Why? Because it possesses the area of minimum term or smallest term, the area of biggest term, whether it's included or not, and then of course the expression that lies between -2 and 6. So we are now required to find the value of x, which will make this entire inequality lie between -2 and 6, where 6 is included. So we want that family of values that basically will show us that being the situation. So what we do is we want to, what's the objective? The objective is to isolate x in the middle. How? Currently x is multiplied by 2, but it is also having 4 added to it. So firstly, we want to get rid of this 4. So we are going to apply the additive inverse to 4. 4 is positive. You want to get rid of 4. So what do you do to 4? You subtract another 4 from 4. Okay, then the plus 2x is still there. But remember, what you decide to do here in the middle, which is what you subtracted by 4, you are going to also apply in the left and on the right. Okay, are we all understanding so far step number 1 of solving this compound inequality? Guys, without fail, you need to constantly be having the objective of eliminating everything else in the middle so that x is isolated on its own in the middle. Currently in the middle, let me ask you, the person who's watching, how many terms are in the middle? How many terms in the middle here? Count for me. How many terms do you see in the middle? How many terms do you see here? Right, guys, when I'm saying in the middle, I'm saying here. How many terms do you see here? Right? Some of you are saying 1. Are you kidding me? Guys, terms are separated by a plus and a minus sign. So you have 4 plus 2x. How many terms do you have here in the middle? 4 is a term. Plus separates. 2x is a term. So here, where the rectangle is, you have 2 terms. All right. So if we read this, what is this saying? It's saying 4 plus 2x is greater than. If you are reading this from the middle to the left and then to the right, please listen to what it's saying. 4 plus 2x is greater than -2. 4 plus 2x is greater than -2. Why am I saying 4 plus 2x is greater than -2? Because I'm reading from the middle to the left. So 4 plus 2x is greater than -2, but less than or equal to 6. This is what this is saying as a compound inequality. So we want the value of x that we could substitute here that will make this entire inequality lie between -2 and 6. That value, or those values of x, we could substitute here in the place of x. They would obviously, those values of x would first have to be multiplied by 2, then added to 4. All in all, this value that we get here should be between -2 and 6 ultimately. Whatever that value is that I substitute here, it should hold true. So what I'm saying, in order to be able to get those values of x, what you first need to do, step number 1, is you need to isolate x. What do we mean by isolate, guys? It means x needs to get alone time on his own here in the middle. Everything else needs to go. Who needs to go? Let's look at the things that need to go in order for x to be alone here in the middle. 2 needs to go. What is the relationship of 2 with x? 2 is multiplied to x. 4 needs to go. What is the relationship of 4 in relation to this term? This 4 is added to the 2x. So what we do first, we need to get rid of the 4. So let's first try and get rid of the 4. Look at 4. How is 4 at the moment? This 4 is a positive number, okay? 4 is positive. We need to say goodbye to him, all right? He is that friend who stayed in our friendship group for too long, and he's not adding any value anymore. So what do we do then to get rid of 4? We apply the additive inverse. We subtract 4, guys. Okay? You subtract 4. But remember, if you are going to subtract 4 here in the middle, what you do in the middle, you have to do on the left, you have to do on the right, you do everywhere. So if you subtract by 4 here, it means we are then going to have 2x alone now, because that 4 is gone because we subtracted by 4. But remember, we have to calculate as well. What's minus 2? We subtract the 4 here as well. We get -6. We subtract the 4 here as well. We get +2. Aye, we are coming close now. We are getting there. Ne? Next step. Okay, so we first applied the additive inverse. Or you could say you transpose, because guys, additive inverse is just the concept that lies behind the explanation of why we say you move something and then the thing changes the sign. This 4, you move it to the other side, it becomes -4. Take this 4, you move it over to the other side, becomes -4. Once you move it, it disappears from the middle. You are left with 2x. Does that make sense? I hope you understand, guys. Okay. Now, let's check first if people are with me so far. How I got to 2x and how I got the 4. That friend that basically has overspent his time in the relationship had to get rid of him, of her, eventually, because she gossips too much. 4, he gossips too much, man. You know, every time secrets are shared with this friend, he goes and tells the others. So he needs to leave the relationship. He needs to leave us. So we just subtract him. We take him away by subtraction. But we also take him away here. We take him away here. Okay. Okay. Right. Thank you so much. There, Siziwe for carry. Siziwe. Sing the errors. I love this. Okay. No. Be careful, Dark Dindigul. Is it Dark Dindigul? No. Okay. I made a mistake. Thank you so much to Siziwe for carry there. I just omitted to put the equal sign. Okay. Now we have 2x in the middle. All right. Now we need to get rid of this 2. But what is the relationship of 2 with x? 2 is multiplied. What combines 2 and x together is multiplication. So how do you get rid of something that is multiplied? You divide, guys, by that thing. But remember, what we do here, we do there, we do here. We divide by the 2. We divide by 2 here, we divide by 2 there. What do we get left with now in the middle? X. That's what we wanted. Isolating X in the middle. All right. Now you have officially gotten rid of those negative, impactful friends in your life. All right. With the hope of basically ensuring that you are able to solve some of the problems that you've been having because you've been having the wrong kind of influence. You see? So X is left alone. What's negative 6 divided by 2? A negative divided by positive, ki negative into 6 divided by 2, ki 3 into 2 divided by 2, ki 1 into ki answer le. Ki fedile. Ki qibile tata. Ki fedile, ki qibile, ki tata, ki tumetse. Yabo, ki tumetse. So there's the answer, guys. That is basically our arrival. So X must be a value that lies between -3 and 1, where 1 is also included. You see, X must be between -3 and 1. In other words, when X is greater than -3 but less than or equal to 1, the values that lie between -3 and 1, where 1 is also included, are the values we can substitute in this particular inequality that will satisfy this inequality. It's not just one value, it's many values that you could substitute in the place of X. Okay, yeah. If I was to speak about specific integers, -3 is not part of the answer because it's not included. There's no equal sign. If there was an equal sign, we would say it's part of the answer, right? But remember, what did they say here? Represent the solution in the interval notation. Currently, this is in the inequality stage. What is the interval notation? Guys, when you have less than or greater than, for interval, open brackets represent the not included value. When you have less than or equal to or greater than or equal to, we use square brackets. Okay, so if you are including a value, you use square brackets, right? Yeah. There's also something else here, that when you have a number line, because sometimes we get asked to represent your answer in a number line, shaded dot also means you are including a value, and that also speaks of square brackets. But your less than or greater than with no equal sign is your open brackets, and we use an open dot when it comes to the number line to represent such. So if we were to write this in interval notation, we would say X is an element, then for this less than, we use an open brackets, we write -3. We say -3 to what? To 1. And since there's this less than and equal to sign, remember what did I say, the less than equal to or the greater than equal to sign, it means square bracket. So I'm going to use a square bracket at the end. Okay, so the answer is from -3 to 1. Okay, from -3 that's not included to 1 that is actually included. That would be what I call interval notation. Okay, then sometimes they ask you to write your answer and represent it on a number line. So you write the -3 here and you write the 1 there. Remember I said open bracket means open dot. So above the -3 I would write an open dot. And then square bracket means shaded dot. That's when basically you are saying the number is also included. So we would basically shade like this, right? And then we're saying the answer lies, X is greater than -3 but less than or equal to 1. Greater than -3 is this side. Less than -1 is this side. And then of course if if 1 is included, we are shading to show that 1 is also included. It's part of the answer. Okay, so this would be if they had asked for us to represent our answer on a number line. I'm sure this reminds you guys of interval notation, set builder notation, and then also representing answer on a number line. Okay. Yeah, so this is, I don't know, if you have any questions specific, please ask. This is your time to shine. You can ask your question. Ask it before you lose it. Okay, let me mute my mic. No, Doc Dindy. All right, that's not to say that a negative number can be included. Remember, if the inequality sign here had been equal at the bottom, if there would have been an equal sign here, then I would have basically used a square bracket here. Remember, the square bracket is just used to indicate inclusion of a number. Here, negative is just not included, so it's just a coincidence. It does not mean that negative numbers are never included and it's only positive numbers that are included. Okay, so don't interpret it that way. That's a wrong assumption to make. It's an incorrect assumption that you are making. So for inclusion, it just depends on the question. Okay, please. That assumption is very dangerous. If it was -3 and -1, well, if it was -3 and -1, it would still, all right, the question has less than, so it will be -3 and -1. So that one has less than, that one has a less than and equal to. We would still say open, whatever the answer is, square bracket, whatever that answer is. Okay, you're almost there. All right, let's see if we can't. Let's look for some different numbers. Okay. Let's just do a different question. Okay. Labs, can you please do factorization of trinomial? Can you please send me a gift that would basically encourage me to do that, Lebza, if you will? I appreciate that you guys are loving the live, guys, but I'm telling you, you'll motivate me like nobody's business if you can just support my live goal. All I want, guys, is 1,000 roses. If you can check out my live goal, that's even if you guys are not bothered. I'm actually bothered that you guys don't even see my live goal. Oh, please, and do tell me if you think I'm too much by saying that I want support for my life goal there, guys. Please, come on. Let's say, let's do this. Thank you so much, Doc. I really appreciate it. I just I want to change this up a little bit here so that we can get things a bit exciting. So Doc is saying that she's very close to understanding. Okay. Let's say that we had this, okay, -7 less than or equal to 3 minus 2x less than or equal to 5, because I'm reading from left to right. But if I'm reading from the middle to the left to the right, then I'm saying 3 minus 2x is greater than or equal to -7 but less than or equal to 5. I hope that makes sense. So let's do this. Step number 1, what do we want to do? Isolate who? Mr. X, because X needs to be isolated in order for us to have the answer. So what do we do first and foremost? We look at how many terms we have. We have 2. Who is this? It's 3. It's a constant. He needs to go. Is that friend? I told you guys, that friend that gossips too much, that just needs to leave. Give us some privacy. Hopefully we can be able to think better without a gossipy friend that has all these things to share. So then what we do is we basically going to do what to 3, because 3 is positive. We need to get rid of him. So we can transpose him left and right, but when we do, obviously he leaves the middle and we are left with negative 2x. We know that means we are subtracting. This is a 3 that's positive. We subtract 3. We apply the additive inverse. Okay, so if we subtract 3, that leaves us with 2x here. Obviously, subtraction of 3. Okay, hopefully that makes sense. Okay, and remember, we are subtracting 3 there as well. So we are left with negative 2x. Now we can see it. Oh, okay, negative 2x is left behind. 5 minus 3 is 2. Negative 7 minus 3 is negative 10 and 2. And we are very close to our answer. Now we have a negative 2x in the middle. Okay, so what we are going to do now is we are going to divide by a what? By a negative 2. Guys, let me say this. If you decide to show the division, then you have a moral obligation that in that moment you decide to show the division of the negative coefficient for the middle and the left and the right. You must change the direction of the inequality sign. Your inequality sign needs to be reversed when you divide by a negative. The emphasis is division by a negative where the coefficient of x is concerned. If you do that, then the inequality signs need to be reversed. Please, guys, do that as a matter of like ASAP stuff. You show the division. If you do, then you must indicate the reversal of the direction of the inequality sign. So you see, this is how it was, but now we are looking in that direction. What's a negative divided by negative? It's a positive. So we have positive what? 5. Negative divided by negative, positive. 2 divided by 2, 1. We are left with x. Negative divided by positive, negative. Negative what? 1. Now, the reason we reverse the inequality sign when we divide by a negative is because that's how this inequality statement becomes true, not false. Had we retained the signs in that direction, then it would have been a false inequality that we have there. Okay, so I'm sure you can see that negative 1 is the smallest number, whereas 5 is the biggest number. So then we can then conclude and say, therefore, we always write the small number this side, guys. Do you see this inequality sign? That this inequality sign, I usually call an inequality sign, guys. I like this game. You know Pac-Man. Do you see where Pac-Man is opening his mouth towards? Pac-Man is opening the mouth towards the x. So negative 1, if I decide to write here, let's open the mouth in the same direction. We're opening it towards x. Then same thing here. We were opening that mouth right towards 5, the biggest number. All right. So this makes sense as to why we reverse the inequality sign when dividing by a negative, because it's true that x is a number that is greater than or equal to negative 1, but less than or equal to 5. You see? Yeah. So in other words, x does lie between negative 1 and 5. So that makes sense. So please, guys, reverse of inequality sign when we divide by a negative. And then please go ahead and make sure that you finally at the end rewrite the smallest, this is the smallest number on the left, because it's always like that. I mean, even on your number line, the small number is on your left, your big number is on the right. So it makes sense. And look at your inequality signs, they make sense in light of the reverse. Had we not reversed, then it would have meant that our inequality symbols are false when it comes to the numbers that we had represented there. So we must remember to reverse. Okay, so please guys, we play the game of transposing and then applying the multiplicative inverse. These are steps that we take to isolate x. So it's first the additive inverse that we apply, which is basically transposing. The fact that we want to get rid of 3, we move it to the left, to the right. Then 2, multiplicative inverse. We divide by the coefficient of x to get rid of the one who is attached. There are those friends that are so attached, guys, like they're attached to the hip. It's like some of you have family ties with those friends. It's very difficult to get rid of those friends, but you know that they are negative, but they are tied to you. It's like they are attached to you because there's deeper ties that basically tie you to each other. But then you know, it's into this person is negative. So we divide, get rid. You have to get rid somehow, you see, until you get isolated and you can think clearly without any, interferences, if you want. Okay, so I don't know, I hope my dear sister there, we are sorted. Now if we want to write this in interval notation, clearly write to this interval notation, x is an element. Remember I said when there's an equal sign with these signs, you can say square bracket. This is a square bracket. Okay, the minute we have the sign with the equal in it, that's a square. So from -1, you see this one is also square bracket to 5. Okay, -1 to 5. Then if we were asked to write and represent this on a number line, -1 is here, 5 is here, really smallest, biggest, shaded. You connect because it includes -1, it includes 5, and all the numbers in between, all those real numbers. Okay, so yeah, grade 10s, this is you, all right? Okay, remember that the only reason why I now have put emphasis on this particular question and answering it is because people were asking. Okay, yeah. Okay, I think proud you've been answered. The Lungelo Xaba, proud is answering Lungelo Xaba. Very true that when you round off, guys, remember when you round off, you round off. Labs are saying do factorization. What did I say to you, Labs? You want me, you have that's a request, my guy. You see, I had already done factorization. I did cubic factorization, I did grouping, I did difference of two squares, and then I also did trinomial factorization. So yeah, we did that. In my YouTube channel, when you watch the live lesson that I did previously for this grade 10 paper, because I started this grade 10 paper and I did it from 1.1.1 to 1.5.3. Today I picked it up from 1.5.4, and I've had to answer other questions that you guys have asked and requested, and I've done that because you asked and requested. Now I needed to get into this question. Okay, question 2.3, 2.4 and 2.5. Need to finish this paper off, guys, so that at least question 2 is done. And I think there's question 3 that's coming up as well. So yes, guys, YouTube channel link is in my bio. The link is in my bio. The name of the channel is also called Maths is a Game. You'll see it by a white profile picture, guys. And yes, for now, picture quality when it comes to the YouTube videos, I am uploading, guys, from my phone, the same videos that I'm doing. So you can see this movement. I'm moving up and down, It is small picture videos, of course, because we're not full-blown quality yet. You know, that time is coming. You need to just be patient with me, guys. You know, bear with me. Many people have told me this, but for now it's just that even my circumstances are not allowing me to have that freedom or that liberty yet. But in good time, guys, we'll get there. So for now, proud 6373 for this channel, this TikTok page here, I do grade 8, 9 and 10. But there's another TikTok page which is also Maths as a Game, where I do grade 11 and grade 12. So here on TikTok I have two channels. This one, which is for grade 8, 9 and 10. I think we just recently reached just about 20k followers on this one, grade 8, 9 and 10. Then the other one is grade 11 and 12. That one I think is roughly about 40 something k followers. But like those people, that page is the one I started with from the beginning, you know. So yeah, it's been around for longer. This one is fairly new, this one that we are in here. Okay, 2.3, solve for x and y simultaneously if, right? I think we can end on this note. Let's say end on this note 2.3, because unfortunately due to time I also have to clock out. Okay, I have to clock out. Yeah, Proud, thanks for answering a person's question there in the comment section. The person was asking about rounding off. You are a good person, good man. Okay, and thank you guys for the gifts. I really appreciate them. Yeah, thank you so much. Which grade here? This is grade 10. So for x and y simultaneously, x plus 3y minus 5 2x minus 6y plus 2 is equal to 0. Karabo, you have a question, don't you? Surely you joining in and out is there must be a question lingering there somewhere. Okay, solve for x and y simultaneously. So guys, with solve for x and y simultaneously, we have two methods, and I'm going to do both methods. There's a substitution method, right? And there's also an elimination method. Okay, but this one is substitution and elimination method. This is elimination method as it applies to your linear equations grade 10. Eleanor, I don't do grade 12 here on this page. I do grade 12 on my other Maths as a Game platform, which is here on TikTok still, but the one with the white profile picture. If you can search for that. It's been a minute, by the way, that I've done grade 12. Yo. Yeah, it's just that remember the transition of kids from grade 8 and 9 from last year, grade 9 from last year, who have started to do pure maths in grade 10. And if you know anything, you know how it is with grade 10s that are doing pure maths. We want more people doing pure maths than maths lit. So I'm just trying to support those kids here so that they can develop confidence in their maths. So x plus 3y minus 5 is equal to 0. So we have equation 1 here, and we have equation 2. And the question says solve for x and y. So we want x and y. So the substitution method, this is how the substitution method goes. You look at these two equations, and the tendency is we like looking at the equation. We look at the variable x, the coefficient here is 1, variable y, the coefficient is 3, variable x coefficient is 2, look at the variable y, the coefficient is 6. So we grab, guys, the equation that has, ideally, the easiest to do is when we actually take the equation with a variable that has a coefficient that is 1. So what you're going to do with equation 1, we're going to say x plus 3y minus 5 is equal to 0. We are going to isolate x on the left, because why are we isolating x? Because we can see x has the coefficient 1. Then what do we do to 3y and minus 5? They cross over, Jordan. And now what we do is that we take now this equation 3 and we officially call it equation 1, and we officially call it equation 3. Then step number 2, you substitute this new equation that you have just formed into the equation you did not touch. Which one is the equation you did not touch? You did not touch equation 2. Okay, so let me just recap again. You have x plus 3y minus 5, which is equal to 0. That's your equation 1 that you were given. Then you have 2x minus 6y plus 2 is equal to 0. That's your second equation you were given. Now you take your first equation here simply because you can see the coefficient of x here is 1. It's so nice, guys, to take that equation that has the coefficient of 1, and then whatever variable it is, you make that the subject, or you isolate that particular variable, all right, so that you can form a third equation, which you will then prepare and make ready for the purpose of substitution. So remember, equation 1 is now x is equal to negative 3y plus 5. 3y, we transpose it from positive, becomes negative. Minus 5y, we transpose it from negative, becomes positive. So that's equation 3. So now we're going to substitute this equation 3 where exactly? Into equation 2. Where is equation 2? There it is. So what that means in essence is that everywhere we see x, who is going to replace x, guys? Everywhere we see x, this is the note I want to make. Everywhere in equation 2 where you see x, you substitute the expression. Which expression? You substitute. Who do you substitute? You substitute negative 3y plus 5. So I'm just making the point. Everywhere where in equation 2 where you see who? X, where you see Mr. X, you substitute who? Well, you substitute the expression of negative 3y plus 5, who is x. So let's go to equation 2 and go write it down. The first thing you see in equation 2 is 2, this 2. Then followed by a what? A x. What did we say? Everywhere in equation 2 where you see x, you substitute who? Negative 3y plus 5. So in brackets, very good, proud, we are going to substitute in the place of x. In the place of x, using brackets. Okay, substitute who? In brackets. Okay, that's a very important point to make. You use brackets to substitute. So where x is, you are going to substitute negative 3y plus 5. Let's put it, negative 3y plus 5 in the place of x. What follows thereafter? A minus sign, with this minus sign, and then what? A 6, then what? A y, then what? A plus 2, then what? A equal to 0. The substitution has been successfully completed. Bluetooth has been successfully connected, right? Now, after doing so, let us expand, simplify, solve for variable that is dominant. I'm sure you guys can see which variable is dominant. You expand, simplify, you solve for the variable that's dominant. Now this should be quite straightforward because we are simply now applying the knowledge that we have. Distribute the 2 to negative 3y, we get. Distribute the 2 to positive 5, we get. Minus 6y plus 2. Then you have negative 6y, you bring the like terms together, you transpose the others to the other side. Positive 2 is negative 2, positive 10 becomes negative 2. negative 12y is equal to negative 12, because negative 6 minus 6 gives you negative 12. The y basically remains equal to negative 2 minus 10 is negative 12. Now you know most, you want y, so what do? You apply the multiplicative inverse. You divide by the coefficient of y, which is negative 12. What you do on the left, you do on the right. The answer becomes y is equal to 1. We are not done, because the question did not say solve for y alone. It said solve for x and y. We've just accomplished the first thing, which is to solve for y. Now, so I'm going to make that note. We are not done. Now substitute. What are you going to substitute? You substitute the other variable. Where do you substitute the other variable? You go and substitute the other variable in equation 3. Okay, because equation 3 is ready to cough out the value of x. It's just waiting for y so that you can substitute it there and then get the value of x. Do you see this, guys? The value of x is close to being solved. All it's waiting for is for you to substitute into equation 3 the value of y that you got. So let's write the equation 3. X is equal to negative 3. In the place of y, there we write 1, and then we add what? 5. So that means negative 3 plus 5, because negative 3 times 1 in brackets is of priority before we add and subtract. BODMAS says so. Brackets first, and then addition second last. So the negative 3 plus 5, that is positive 2. So what you have now is x is equal to 2. And in all honesty, you could write this, if you wanted to, as a point. X is 2, y is 1. Because remember, the answer you get here is what we call a point of intersection between two lines. Okay, remember, this is a straight line equation, and this is also a straight line equation. So with these two lines on the Cartesian plane, where these two lines, let's say this is f of x, we say this is g of x, where these two lines meet, this is what we call the point of intersection, and it is obviously represented by an ordered pair, x and y. Okay, guys, I hope this question was clear, the solve for x and y as well. I think I'm going to hold it right there for the night, guys. I think it's quite a meaty session, live session that we had here. Hope it was beneficial to you guys. Okay, we will be checking out the rest of this paper tomorrow. Okay, yes, proud, definitely be checking more out tomorrow. Thank you so much for those that joined in. I want to thank you heartily, guys, for the gifts that you shared as well. They mean the world. Okay, yeah. Same time, guys, same time. Okay, same time in the evening. It will also I will also be going live, I think, during the day sometime, we'll see though. Maybe there at 3ish, maybe at 3 or at 2:30. Okay, 2:30 during the day I'll go live again. But yeah, tomorrow. Thank you so much, guys. Again, thank you for the gifts, and yeah, thank you for supporting as well the live lesson. Really appreciate it. I think today we got 24 roses out of the 1,000 that were set out. Hopefully we can try and really do better there with the roses. Really, guys, the romantic roses. That's fine. If you aren't back from school, we'll be saving the live lesson on the YouTube channel anyway, so whether you're back or not, that's fine. fairly good. I'll definitely see you guys in the evening then. Like I said, I know it's Friday night and I know people do a lot of things, but I hope you guys can sacrifice for the purpose of this. Okay. Thank you so much, guys. Have a great night. And yeah, thanks, Lakani, for Shoabiba. Thank you. Lakani, for thank you. Proud definitely will be doing those types of questions, equations, don't worry. Yeah, we'll do more. Definitely do more. Okay. Alright. Well, have a good one, guys. It was good. Ciao.